All right, so next up with vectors is we're going to look at vectors in two space, which essentially we've already done. But we're going to also look at vectors in three space, three-dimensional vectors. And so that's what these R2, R to the power of 2 means, is R stands for all real numbers, and 2 stands for two-dimensional. And so, again, it's a funny-looking R. It's kind of got like a little line beside it. And again, this is the set of all real numbers. Let me print it in there. All right, so that's the set of all real numbers. And when you're talking about R2, for example, that's, like I said, all the real numbers on the x-axis and all the real numbers on the y-axis. So that's what we're looking at there in two space. Where in three space, again, R3, we're looking at three different axes, x, y, and the z-axis, which we're going to look at drawing vectors three-dimensionally today, which is a challenge for me because, well, I'm artistically a little bit challenged. Now, like I said, we've dealt with two space probably since you were in grade 9 or grade 8 or grade 7. And so if I draw the vector 4, 3 on what's called the xy plane, and note, a plane is a theoretical wall, ceiling, floor, just in other words, a flat surface. And so when I draw the vector 4, 3, the beginning is always at the origin. All right. And then, of course, we move over 4 to the right on the x-axis, because x comes first, and then 3 up on the y-axis. And so our finish is at the point 4, 3. So I'm going to draw that vector. There we go. And I'm going to call that, and again, that's point B there. And so this would be vector OB from the origin to point B. All right, and note the x and y of point B, which is 4, 3, are the components of the vector and are found at the tip of the vector, and the tail is, like I said, at the origin. Now, next up, three space. So now I want to draw the vector 3, 4, 5 on the xy plane. Now, just to explain the xy plane, is that the x is coming at you, towards you. All right, so a positive x value is towards you. A negative x value would be away from you. A positive y value is to the right. A negative y value would be to the left. And a positive z value is up, and a negative z value would be down. Now, because it's three-dimensional and we're drawing it on a two-dimensional surface, there's just a little bit of a, there's going to be a challenge there. And so what I'm going to do is that I'm going to, first of all, I should put a note here, is that the x and y and z point of a point C, 3, 4, 5, are the components of the vector. And that's what's hard, is because we've got to draw the tip of the vector from the origin, which again, the origin there is my blue dot. So what I'm going to do to draw this three-dimensional vector on a two-dimensional surface, and again being artistically challenged, I'm going to use what's called use a rectangular box to draw the vectors. All right, so here's how I'm going to do that. Let's see, I'll get out, I guess I'll use blue. So there's our origin right there. Now, C value is going out 3. So I'm going to count 3, and again, this is when our point C here, x, goes in order here, alphabetical order, x, y, and z points. And so the x is going to go out 3. So I'm just going to put an edge of a box right there. The y value is going to go out 4, 4 to the right. 1, 2, 3, 4. And the z value is going to go out, now again, hold on here, I'm going to create a box, the bottom of the box, by kind of, I guess, joining the x and the y, by going out 3, but then right 4. So there's the bottom of my box. Now to include the z value, which is up 5. So 1, 2, 3, 4, and 5. Now, and to include our y values and x values, so the x value, I'd go from that z value towards me 3. The y value, I'm going to go from that z value right 4. All right. Now, you can see this is developing a box, and actually I'll draw that box in here. Connecting the points. There we go. There's the bottom of our box here. We'll draw that in here. Now we are missing the corner of the box. And the corner of that box is the end of our vector, the tip of our vector. Because again, the start of it is at the origin, and the tip is going to be at the corner of the box. So I'm just going to kind of draw in that corner of the box. Trying to do my best here, so I just sketch along. There we go. It's actually turned out pretty good for me. Again, I'm artistically challenged. All right, now this tip, this corner of this box, as I said, that is the end of our vector. And so to draw this vector three-dimensionally, I'm going to go from the origin to the edge of that box. And that red line there is our vector OC. And there we go. Because if I just drew the vector like as you see it right there without the grid, and I just drew it like that, well, that doesn't really help us all out. And again, just to draw that rectangular box gives us a three-dimensional representation of that vector. And I know if I can do it, most of the other people can do it too, because as I said, I'm a little artistically challenged. That's what happens when you're a math teacher, I guess. All right, now, speaking of rectangular boxes, it says the points A, B, C, D, E, F, G, H create a rectangular prism in R3, which again is three-dimensional space. And here's the coordinates of all our points. And it says plot the points on the XYZ plane below, or grid below. All right, so it says we got point A, which is 0, 0. Well, that's the easy one. That's right here. So I can, I'll put point A right there. There's an A. All right, B is 0, 5, 6. All right, so we don't move on the XY plane, but we go right 5, because it's on the Y, and up 6. So there is point B right here. Point C is 4, 5, 0. So again, 4 outwards, because that's the X value, 5 up. So there is, or sorry, we don't go 0 up. Sorry about that. Let me count that again. C, we're going 4 out and then 5 to the right. So there's my C value right there. All right, D, which is just 4 out and then go nowhere. So there's my D. E is 4, 0, 6. So 4 out, then 0, and then up. So E is right there. G is don't go come out, don't go right, but just go up. And so there's my G value right there. And again, it's just labeling points here on our graph. So then H is 0, 5, 0. So don't go out, go 5 to the right, and then there is H. All right, and which one are we missing here? F. Oh, how did I just skip by F? I have no idea. But anyways, we're missing F, which is 4, 5, 6. Now again, to draw that, that's the other corner of our box here. So again, I'm going to draw the box in. All right, so we get our points. All right, so again, to draw in point G, which is going to be that extra, or point F, sorry, which is going to be the corner. Go straight up, parallel to side ED. Let's see, go across, because whoops, they got to be nice and straight. There we go. And so right on this corner here, which is point F, 4, 5, 6, 4 out, 5 to the right, and then up 6, there's our point F, which again is point 4, 5, 6. All right, now we get to equations of planes. All right, so it says questions here. State the equations of plane ADCH. Okay, so let's see here. Let's go with red. So ADCH. Again, a plane is like a wall or a ceiling, or in this case, the floor. And when you're coming up with the equation of a plane, what you're looking at is what coordinate stays the same on this plane. That's how I look at it. I always struggle with this. And so, like, if you look at point D, it's 4, 0, 0. C is point 4, 5, 0. Okay, see what they have in common there? The Z value is 0. Also, the X value is 4. Okay, so now I try H, which is on this plane, and point H is 0, 5, 0. Well, the Z is a 0, and then point A, well, it's 0, 0, 0. The common coordinate of all those points of A, D, C, and H, the one thing that they have in common is that they have no height. Z is equal to 0. So the plane ADCH is the equation C equals 0. Because for each one of the points on that floor, your height is 0. That's why it's the floor. All right, the next one here, GEFB. So GEFB. Back to G. All right, so what's the common point that these all have between E 406, G 006? What else do we have? F 456. And if you inspected all those points, you realize that the common value, or the equation of the plane, is Z equals 6. Every point on that ceiling has a height of 6. All right, next plane here, EGAD. So now we got a wall. All right, now again, if you looked at all the coordinates there on that of those 4 points, EGAD, you will see that they have a common value, is that none of them go to the right, which means, in other words, Y is equal to 0. Oops, I need that wall off there, that color. Y is equal to 0. There we go. All right, next plane, BFCH. Where we got that? So BFCH, another wall. And what's the common coordinate of all of those values? If you have a look, or if you just look at, it's a wall, and they all have a Y value, which is left and right, of Y equals, let's see, the B value is 5, F, B value is 5, C value, so in all of these, Y is equal to 5. All right, next up, we have plane GBAH. GBAH. There we go. That's that back wall. And all of those have an X value of equal to 0 because it's a back wall. It doesn't come forward at all. All right, and then the last one, plane here, EFDC. Well, we have EFDC here. It's our front wall. And because it's a wall, it's coming out towards us. And each coordinate on those points has a X value of, well, let's see here, E is 4, F is 4, D, you can see, is 4. They don't have any other value that's the same, but they do have an X value that is the same as X equals 4. And those are all equations of walls, ceilings, and floors. Now here's another one. We have, what plane is parallel to the XY plane, but not the same plane? Okay, so the XY plane is in fact when you have Y is equal to 0. Because the XZ plane is in fact the plane that the X and Y, or X and Z, sorry, X and Z axes make. And so a plane that would be parallel to it, but not the same, would be the green wall, right? Would be the other wall. We have the red wall, which is the XZ plane, and the green wall here that I have is is parallel to it. And so I would say it's the F, B, H, C plane. Another one here. What plane is parallel to the XY plane? Well, the XY plane, what color should I do? Let's go in yellow here. Is the plane, the wall, that the XZ plane make together. So the X and Z axis make the plane in yellow here. That's the wall. And what plane is parallel to it, but not the same as it? Well, that would be the front wall, because the YZ plane is our back wall. Well, the front wall would be parallel to it, which would be the, EF, CD plane. And there we go. Now the last thing it says, what is the set of points that represent the rectangular prism? So what is the range, kind of basically the domain and range? We've done that before, but the domain and range always refer to a two-dimensional figure or drawing. In this case, we have three-dimensional. So we just say it's what's the set of points? Well, in terms of our x points in this box, well, the back wall is x equals 0. The front wall goes all the way up to x is 4. And so the set of points in terms of the x values is you go from 0, less than or equal to. We're talking about our x values, again, less than or equal to, and they go up to 4. Now, our y values, again, they go from 0 all the way to the right of 5. And so our x values, our y values, start at 0 and are equal to it, and they go all the way up to 5. And then lastly, our z values, because again, three-dimensional, we start at 0 and we go up to a height of, 6. And so the set of points, our z values start at 0 and equal to it, and they go all the way up to 6. So when it's asking for what's the set of points that represent this rectangular prism, essentially, I guess you're looking at it as a three-dimensional domain and range. Only they can't call it domain and range because we have 3 different axes to worry about, not just 2 of them. And there we go.